So, kinetic theory discussion. Everybody should have this particular paper in front of them, kinetic theory discussion, and we're going to look at the slides and our PhET demonstration and fill in this information about kinetic theory. So the first thing we want to do is recognize the four states of matter. They are solid, liquid, gas, and plasma. So that first line on your discussion organizer, the four phases of matter are solid, liquid, gas, and plasma. Recall that I'm going to keep going. You can pause the video if I'm going too fast. This asks us what makes them different. So what is the difference between a solid, a liquid, and a gas? And we've looked at the PhET demonstration. In a solid, the particles are closer together. They're more dense. They have lower temperature, lower speeds, more bonds between them, more connections. In a liquid, the particles have a higher speed, they have a higher temperature, higher energy, therefore they're overcoming the bonds that are holding them together, but not completely overcoming them, so they're still linked to each other, but they're able to slip and slide around past each other. In the gaseous phase or state, they have enough energy to completely overcome the attractions between particles. They have higher temperature, less density, more energy, more space between particles, more speed, and less to no bonds between particles. And in a plasma, that's where the pieces of matter themselves are starting to gain and lose electrons and form ions. A plasma is an ionized gas. So the four phases of matter, again, for the first part, are solid, liquid, gas, and plasma. The next section says to draw the phases of matter pyramid. So the phases of matter pyramid is here. We've got gas up here at the top, and solid is our phases, and liquid over here. And then what happens to, what do we call those changes between phases? Going from solid to liquid is melting. Going from liquid to solid, we know, is freezing. Going from liquid to gas is evaporating. Going from gas to liquid is condensation. And then two that we might not know as well, sublimation is going from solid to gas. And the way I remember these is if we put the S in sublimation near the S in solid, SUBLIMATION, sublimation goes from solid to gas. So put the S by solid and it goes up towards gas. Deposition is going straight from gas to solid. It's both of these phases on this part of both of those changes on that part of the triangle completely skip the liquid phase. They go from solid to gas and gas to solid. So we need to know those 6 phase changes, and we're calling this the phases of matter triangle. Look, so this is why we're calling it a triangle, right? Next, we want to fill in the table to kind of remind ourselves of some of the data we collected the other day when we were looking at this PhET demonstration. So if we have a solid, if we're looking at the first part of your table now, we filled in this part, we filled in that part, and we're going to work on this table now. If we add a solid, is its volume fixed or variable? Fixed or variable? So if you had a solid piece of iron and you put it in a bowl, you put it on your desk, does the shape of it or the volume of it change? Both of those are fixed. If you have a solid object, the volume and shape are fixed. The space between the particles in a solid relative to liquid and gas is low. They're close together. The attraction between particles is high. They're very close together, so the attraction is high. The speed or energy of the particles in a solid is low, and the particle density is high. They're very dense. The most dense is in the solid phase. So let's look at that. We said that the space between particles is low in a solid, and here it is. The space between particles versus a liquid and the gas, the space between particles is low. The attraction between particles in a solid, there's more attraction between the particles than in a liquid and a gas. That's what makes them so rigid. The energy, the speed of the particles is low in a solid versus a liquid's faster, and gas is even faster than that. And finally, particle density. The particles are the most dense in solid. Liquid, they're spread out. And gas, they're spread out even more. So that's how you fill in that table. In the liquid phase, the amount of liquid that you have remains fixed. The amount of liquid is fixed, but the shape varies because a liquid will take the shape of whatever container it's in. So the shape would vary. The space between particles in a liquid would space between particles is higher than, more than solid. So more than solid. The attraction between particles is less than solid. The energy or speed of the particles is more than solid. And the density is less than solid. And you can go open your PhET demonstration if you want. The space between the speed of particles is higher, the space between them is higher, the density is lower, and the attraction or space between particles is lower in a liquid. And finally, in a gas, the volume and shape both vary. The volume and shape both vary. The gas would take the space and size of whatever container it's in. The space between particles is much higher. It's very high than a solid or a liquid. The attraction between particles is very low. The speed is very high. And the density is very low. Kinetic theory. Kinetic theory of matter is that the particles of all matter are in constant random motion. Kinetic theory is that the particles of matter are in constant random motion. In a solid, they have less motion. In a liquid, they have more motion. And in a gas, they have even more speed, more motion. But the particles of even a solid are vibrating in place. They're in constant random motion. Energy moving into a substance. So if we've got energy moving into a substance, for example, if we have our phase change where we are going to, we've got a solid and we're going to put energy into this. Energy in, we're going to make the particles of this substance move faster. So energy is added to a substance, it gets warmer. And the particles move faster. This is an endothermic phase change. Energy is moving into the substance. The particles move faster. The substance gets warmer. Which phase changes are a result of particles moving faster? So that would be melting, evaporating, and sublimation. Which phase changes would you add heat? Would you add energy? Would you make the particles move faster? If we think about our phase triangle, both of the ones going to gas because that's the highest amount of energy. So both of those, sublimation on this side, evaporation on this side, And then solid to liquid, the way we had it drawn, melting also makes it warmer or particles move faster. So that's our three endothermic phase changes. You'll need to be able to classify phase changes as endothermic or exothermic. Those are endothermic. Exothermic, energy is leaving the substance. So exothermic, we got our solid. Well, let's do that. Don't we got our gas? It has lots of energy, right? And energy is leaving. If energy is leaving, then are those particles going to move faster or slower? They're going to move slower. If the particles are moving slower, is the substance getting hotter or colder? It is cooler. Which phase changes are a result of substances moving slower? So the ones that are getting colder, if this is our phase change triangle, the ones going from gas down. So on this side over here, that's deposition. And on this side, it's condensation. And down here, we're getting colder, so freezing, right? Going from liquid to solid. Freezing.